In this video, I want to look at two different ways we can think about finding the mean. The first method is known as leveling out. Let's look at finding the mean of 7, 5, 6, 2, 1, and 3 using this method. In order to do this mean with leveling out method, we need to look at them as towers of the given height. So if the numbers are small enough and we have the materials, it may be helpful to physically build these towers out ourselves. The idea of leveling out then is to keep the same number of towers that we have here, but we want to try to make them all the same height. So we would start taking blocks off of the tall ones and moving them to the small ones to kind of balance out the height of these blocks. So as we do that, we're slowly leveling out the heights and finding the means. And then once they all have the same height, the height of these blocks is going to be the actual mean. So now we have all the same height. They're all of height 4, so the mean is going to be a 4. Let's look at another example. This time I have 8, 5, 7, 6, 4, and 3. And I'm going to do the same thing. I'm going to take the blocks from the tall towers and move them to the short towers until I can try to get these to all be equal height. And as I'm doing that, I see that I'm going to run into a small problem. Here, if I start moving these blocks over, it's not going to work. So instead, I'm going to have to think of kind of breaking these blocks in half and moving half of it over. When I do that, each one of these will be 1, 2, 3, 4, 5 and a half. So the mean would be 5.5 or 5 and 1/2. So if the mean is not an exact whole number, we may have to think about cutting these blocks into pieces and moving pieces over instead. The next way to think about the mean would be as something known as the balance point. Let's go back to our first example, 7, 5, 6, 2, 1, 3. The idea of this is I'm going to put these numbers on a number line. Here we have 1, 2, 3, 4, 5, 6, and 7. And then I really want to build a dot plot. So we have a value for 7, a value for 5, for 6, 2, 1, and 3. So the idea of finding the balance point using the mean is to think of this line and think about it as that we want to balance it at a center point. And I can see that if I had this actual physical line with these little objects on it, then it would balance at 4. I would need to put the point of this triangle right at 4 in order to make this thing balance. So the mean would be 4. This time, let's think of this dot plot here. We have 2 1s, 3 3s, 4 4s, and 3 5s. And we can see that if we were to put this triangle right at 3, then this side would be a little too heavy and it would tip down. If we were to put it somewhere here like 4.5, then this side would be too heavy and it would tip down. With numbers like this, it might be hard to exactly see where this balance point is. In this case, it turns out to be at 3.5. If I were to put my little fulcrum right here at 3.5, then this line would be balanced. And so one way we can do it is we can find something like a marker or a triangle or something like that, and use a ruler sitting on top of it, and then put these numbers at the appropriate points. And then see where it would balance. So we could put this at 1 inch, maybe some counters at 1 inch, at 3 inches, at 4 inches, and then at 5. Like I said, we could use counters or something like that, and then we can kind of move this lever along, or this fulcrum along the ruler to try to figure out exactly where this balances. But this method can definitely be tricky to visualize.